Okay, welcome Madhu, welcome Amol. Glad to have you on our Steel and Whiskey podcast here today. How are you guys doing?
Oh, pretty good.
Yeah,
Pretty
doing
good.
And we are also thankful, to have the invite from you, and we are really
Yeah.
excited to, attend this kind of podcast.
Yes, very good. We're happy to have you here. So, um, for our audience who watches the videos on YouTube and isn't listening, you probably noticed my background's a little bit different than normal. So I'm in a different location. I don't normally have my headset and all that on, but I'm at home today. So we are a little different background in that than what I normally have, but that's all right. So,
Yeah.
um. Madhu and Amol, did you want to give the audience here a little bit of a introduction? I see you got matching shirts on, so Mold-Tek is pretty obvious there by the matching shirts who you work for. So
Yes.
why don't you give us a little background on yourselves and the company as well?
Okay, let me start. After my graduation, like in 2003, I have started working for this detailing. Uh, I have joined like in January 2003, and in starting my career, like I got a chance to get trained in US in Nashville. So a couple of months I got training in SDS2, that is particularly version I think 6, and in steel detailing. And I came back to India and I started giving training for a couple of people. And in my previous company, I worked for a decade. And in 2012, I have joined Mold-Tek. Like I have joined as a project manager, and I was doing a lot of projects, like a complex ones with one of the prominent fabricators, wide varieties of things. So like it's almost 2 decades for me in this field,
Yeah.
and here I am now. Like I got an opportunity to talk to you.
Very good, very good. So what is your current role with Mold-Tek?
Like I'm right now associate vice president, steel detailing. I'm heading
Mhm.
like Hyderabad, the SDS2 team branch.
Okay, so you've done probably played a number of roles. Started out as a detailer and kind of probably played a number of
Yes,
roles to get where you are today.
yes. Like I've started as a detailer, like then modeler, then checker, then a team lead, then assistant project manager, then project manager, like then a senior project manager, AGM, general manager, then to this position.
Okay, very good. So you've been in sounds like about every role you can, and so you know how
Mhm.
each one works and what the requirements are for each one. That's a very
Yes,
good, lot of knowledge and very good skill to have and to understand how the whole company works, right?
yes, correct.
Yeah, yeah, very good. And Amal, what about you? Give us a little background on yourself and how you relate to the audience here.
Yes, it is pretty much similar to the Madhu, what he said. And the only change with my career is like I started after my education, I started working as a contractor, for civil construction, but somehow that
Hmm.
was not made for me. And I moved my career like 2005 January in steel detailing industry, and I joined as a trainee or the fresher, detailer in one of the company, and worked there for like 2 years, and then I moved. And similarly, like I worked as a detailer, then shifted as a modeler. Basically, in India, most of the companies run like they create some detailers, modelers, checkers, 3D checkers, 3D modelers, or 2D drawings, detailer, or the erection drawings kind of. And
Hmm.
once we tune with the all roles, maybe we can go up like a team lead or project manager. That's how I also molded myself, and then I joined Mold-Tek back in 2011. Yeah, and yeah, I started my career with Mold-Tek as a project manager, and same thing like Madhu, I'm also working as associate vice president. The only change in my location is, I'm like northwest, It's in Maharashtra state, the city called Nasik. And I'm taking care of this Nasik office, like Madhu is taking care of Hyderabad office. So yeah,
Okay.
that's, and currently the role is mainly in the project coordination, client coordination or estimation, and looking after the critical items of the projects. If there are any issues with the software or maybe some kind of support is needed, of course, we do have the login of SDS2 and so many things we can dig it up from the forums or some kind of plugins. So that kind of roles
Mhm.
I'm currently involved with. So yeah,
Okay.
that's all pretty much.
Okay. Very good. Very good. So before we get too far into this discussion, uh, we always gotta have our whiskey here on the podcast. So I don't want to get too far into a good discussion without
Yeah.
going there. So uh, these guys, so Mold-Tek was nice enough to actually send me a bottle of whiskey before we during the planning of this podcast. After we figured out,
Yes.
when we were going to do things, you guys decided to go ahead and send me something. So again, for the audience watching, this is a really nice packaging. So I very appreciative of this whiskey that you guys sent me. This is great. So pretty cool packaging, nice fancy box. So we got a Royal Salute 21. It's a blended Scotch whiskey, 21-year-old. So have a look inside the box. Fancy bottle inside of there. So pretty cool stuff. I'm excited. Obviously I have not opened it yet, so we get to do the unveiling here on the podcast. But pretty cool. So it says it was created to mark the coronation of Queen Elizabeth II in 1953 and was named after the 21 gun salute fired from the Tower of London for royal celebrations. So yeah, pretty cool stuff. Thank you guys. I very much appreciate this. So
You're welcome. And when Prasad came to know that this podcast is going to happen, and Prasad suggested, why don't we send a whiskey to David? So we said, yeah, that's a good idea, and David will definitely enjoy
well,
that kind of
it,
whiskey.
it can get expensive having to buy my own all the time to have new stocks. So I appreciate the help. So again, pretty cool looking bottle here. So it's a blue bottle, got the plastic on it still. So I better open it up and pour it in here. See what we got. So if I can figure out how to get into it. So, and
Okay.
I don't. Am I gonna have to drink by myself today? Are you still on the clock at work and can't drink or
Yes, I have
I'm
glass of
having
water.
flexibility.
okay? That's okay. That's okay.
We
Wouldn't
are
be
in the
the first.
office. We are in the
Yeah, we
office.
can
So
enjoy on our behalf.
Yeah,
yes,
wouldn't be the first time I've drank alone, so it's okay.
No
yes.
problem.
Yeah, cool cork on it too. So I always got to take a little smell. Smells pretty good. Smells quite strong, but it's actually only what do we have here? It's 80 proof, so smells a little stronger than I think it is, but we'll see.
Must be fruity, I guess.
Right?
Yeah, pretty some cinnamon
Perhaps.
flavor.
So as I'm doing this here, one of the things that we do with SDS2 are kind of one of the ways that we, celebrate our projects. We celebrate our customers, the work that they do with our software. We do what we call it the Solid Steel competition or Solid Steel Awards every year, right? And
Yes.
Mold-Tek has been so basically what it is. Customers will submit their projects to us, SDS2. We have different categories. So we'll have like a small commercial, large commercial, small industrial, large industrial, just to kind of break things up a little bit. And then we do like a internal judging and evaluation of the projects to determine the winner. There's also a customer's choice award that customers get to vote on for their favorite project, basically, that's been submitted. So just a great way for us to celebrate, the work that you guys do. So I think Mold-Tek's been submitting projects to that, right?
Yes.
Yeah. How much have you been submitting projects for a while? What's your
Uh,
yeah?
yes, so far we submitted like 6 times, and out of 6, we got about like 5 times. Out of 5, there are like 3 customer choice, and
Okay.
one is second place commercial, small tonnage, and last the Madhu's project, like commercial large tonnage grand prize in 2021. So maybe I can summarize. So far we got 5 awards. The first one was customer choice in 2018. That was for the Young Living essential oil products located in Salt Lake City, Utah. So that was the first award we got as a customer choice award. The second we got like a small tonnage second place commercial category. That was for a health building, Parkview Health Building that was located in Fort Wayne, Indiana. The third one we got like again with the customer choice award. That was Taylorsville, Utah Temple, located in again Taylorsville, Utah. The fourth one was for Madhu project. Maybe you can say.
Yeah, that is Moro High School that is located in Ellenwood, Georgia. That we received like a grand prize for commercial in 2021. And the latest one is like Gillette Stadium renovation, which is located in Massachusetts. So for this, we received like a customer choice award in 2023.
Very good. Yeah. So this was just the last year's Solid Steel Awards, and
Yes.
this comes at a perfect time for an event coming up here in the U.S. The Super Bowl is just 2 days away, so it's the Friday before Super Bowl Sunday, as we call it here in the U.S. So um, Gillette Stadium, just to make sure, because we have a range of audience here, so I'm sure not everybody is familiar with U.S. football and is up to date on that. So Gillette Stadium is the home of the New England Patriots
Yes.
in the NFL.
Yeah.
They are not going to make it to the Super Bowl this year. They were pretty terrible this year, actually. So they're not relevant to the Super Bowl discussion, but at a time that is a big event for the NFL. So
Okay.
yeah. So this was and it was an addition. The project you submitted and won this award. It was an addition to Gillette Stadium, correct?
Yes, correct.
Yep.
It's a addition on north side. It's a
Okay,
north end.
on the north side. Very good. So you had shared some images. We actually have some site photos here, and then we actually have some screenshots and images from the model as well. So for the lucky people out there watching our podcast on YouTube, I'm going to share my screen and walk through some of these photos. For those of you who are not watching, for those of the audience that might just be listening, we're going to do our best to describe these photos to you to give you a mental picture, mental image here. So just starting off on the beginning here. So the first thing we've got here, we've got a crane. Looks like a portion of that is erected on site here. Is there?
Yes, like it's like some of the steel is erected, but it's not fully erected. So it's in the like early stage of the project. Yeah.
Very good. And looks like we got a little bit of just a different
Yes.
vantage point on this one, right?
Yes, correct. It's some more steel added on the same point.
Yep. And it looks like, looks like we got a little bit of steel laying down there on site on the ground yet. We can kind of see some of that steel laying down on the ground. So
Yes,
looks like some pretty big steel laying down there.
Yes,
Yeah.
some crazy stuff is there. Like we are having some trusses and all. So.
Okay. And another little bit higher up vantage point. How are these?
I think same stage photograph, like but a distance. So from
Did
our
you have
distance.
this one looks like it's up in the air a bit. Do you know how these pictures were taken? Was there like a drone or something to get
I believe so.
images up high? You know? Yeah.
Yeah, it's from drone pictures. That's what
Yeah.
the customer said. So it's
Yeah.
definitely a drone picture
Yeah.
with high
Okay.
quality cameras.
Mm-hmm. Very cool. Very cool. And we got about the same stage, little different vantage point here again, but I feel like we're getting into something different. Okay. So what do we got going on here? Looks like we're
Yeah, the bottom one white columns are called like a cruciform columns. So like it's a
cruciforms.
W,
Okay.
yeah, cruciform columns. Like it's a white flange member attached by like WTs on each side of web. If you see
Mhm.
like all four sides is equal depths. So that is
Yep.
so it's a like assembly of two WTs and a W member. So
Okay.
these are supporting all these trusses. And again, these trusses are supporting, you see the top columns, inclined columns. So that
Mhm.
is upper concourse.
Okay. Very good. So the white steel that I'm seeing on the bottom and the so those are the there's like 3, 4, 5
Yeah,
cruciform columns that I
cruciform.
see in there. That's all part of the addition
Yes,
there.
correct. So
Yep.
all the foundation to the up to concourse level, all are the cruciform columns.
Okay.
Like there are
Okay.
plenty of them.
Pretty I'm sure those are quite heavy columns
Yes.
as well, huh? Yeah. Like how big
Yeah.
how big do you know how big are they, like I guess depth and weight wise? Do you know off the top of your head,
Like
remember how big those might be?
the depth is like the trusses are like maybe some 6 feet or like that,
Mhm.
and the weight is some weight like 12 tons or like 8 tons, 6 tons. Like a lot of varieties are there in that.
Okay.
I don't remember exactly, but we used to like note that on the drawings if it weighs more than 8 tons or something. So we need to note
Mhm.
so that they can careful by lifting those things.
Mhm. Mhm. Okay. Very cool. And yeah, we got another little vantage point here. We can kind of start to see a little bit more of the steel
Yeah,
rising up
correct.
here on this edition, huh? Yeah. Okay.
Yes. Correct.
And a little bit more here. Just a couple different vantage points again. So I've
Yes.
got a question here. So it looks like some of it's white, some of it's gray. Looks like some of it's maybe unpainted. What's
Uh,
the rhyme or reason for what's painted or what's not?
so like these cruciform columns are different paint, and if you see the slope columns are different paint, and
Hmm.
inside like there is no paint. So we are having a different kind of paint system. Like some are architecturally exposed steel. It's a very close to the walkway, and some are like even though we can see but at a distant location, they are having some different kind of paints, and inside are different kind things. So like we in the model we have noted all these paints to the particular members so that if we hit the status we can segregate easily, and once we put exact data and we have verified like couple of times we have put correct data in the model, so
Hmm.
it's easy for us to segregate. So if we want to
Yeah.
cross check something, just filter it in the model and cross verify the drawings. That makes work easy. So
Yeah.
that's why SJS helps us.
Very good. Very good. Glad to hear that. So really it's a matter of what's maybe exposed to the elements, and then some architecturally exposed stuff might be slightly different too then, huh?
Yes, correct.
Yeah, very good. Okay. Another shot here. Okay, now we're seeing a shot from the inside, more the inside of the stadium. We were kind of seeing the images from the outside of the stadium. We're looking from the inside of the stadium now towards this edition. So uh kind of see what it's looking like on this side. Are all of these are cruciform columns? on here?
Yes, like these are upper ones are not cruciform columns. Up to lower certain height is only cruciform columns. They are regular columns. That columns are supporting video board.
Okay, so
Framing.
we're looking at something that's going to be supporting a big video board then.
Yes, like you see
Yeah.
on the other side, there is a video board. So that kind
Mhm.
of a video board comes throughout this area.
Okay.
So there will be added steel that's supporting that video board. It will
Yeah.
be a very big screen.
Do you have any idea the size of that video board to give people an idea of how
I
big?
really like, I did not measure total length, but
Yep.
it's
Okay.
like
Yeah.
hundreds of feet.
Hundreds of feet.
Yeah, for
Wow.
sure.
Wow. Okay. That's impressive. That's a large board to support.
Yes, correct.
Okay. A little bit closer up shot here. So here you can get a little better view of those cruciform columns with the
Yes,
wide
correct.
flange and the WTs. So looks like
Yes.
some pretty good size stiffeners that go in those as well, huh?
Yes, these columns are supporting like all the cantilever members and the video board, and so a lot of stuff is there. It's a crazy connections.
Yeah, looks like it. Looks like it. Now we're getting this is like from the opposite end of the stadium. We're seeing kind of a view of the whole edition now instead of just a portion of it, a little bit further away. So a lot of signage hanging up there. Must have had a few sponsors probably of the stadium and different stuff. I imagine there, huh? That all got to hang their signs up.
Yes.
Yeah. Okay. Now we're on kind of just yep. So we're looking at another different view here, but kind of seeing all that same stuff in here. So still got those cruciform columns. We're seeing some of that, the bracing going in there.
Yes.
Yeah, a few different views here. So is there any additional like seating to the stadium that was in here, or is it the video boards in a big concourse?
It's like there are club level and like on the video board and some like on the back side we are going to see a lighthouse, so observation deck.
Okay. Okay. Yeah, that's so here we're seeing a pretty good view of that video board. That is quite the large video board there, isn't it?
Yes.
Yeah. So tell me a little bit about this project. Like what kind of challenges did you have on this project? I mean, was there specific things that stick out that your team really struggled with or had to, be creative to overcome certain challenges on this, or?
Yes. First point is this is a geometry. So we are having some existing steel first point, and we received as-built drawings. Based on that, we have provided like a modeled first existing steel. But after a period, like the as per drawings, there will be a difference in the site. So we received a field survey. Based on that, we have adjusted, and some of our new steel is connecting to the existing steel and strengthening reinforcing of existing steel. That is the first point. And obviously this cruciform columns and the trusses connecting to the cruciform columns, they are very crazy connections. So like there are too many bolts and clumsy connections. We in SDS2 what we can do is like we can verify if we can insert the bolts or not. So if it is not erectable or it is difficult to insert bolts, like we have to bring it to the connection engineer notice so that we can modify the connections. So this way, like we receive like thousands of connection inputs, which is very difficult to track. The beauty in SDS2 is like we can attach those connections to the particular members. So we can see the latest connection. If somebody jumps in a checker, he wants to check that after a week or 2 weeks, he simply just open the member and see the drawings attached to that. And he can verify if it is exactly correctly modeled or not. So that is one thing. And we are having on this like thermal or fabrica connections, there is an existing steel and expansion joints. So the connections cannot be rigid. It can be like slide. So we
Okay.
have to model like a fabrica pads in that. So that kind of a stuff we can input. That is one
Yeah.
thing. And second one is like we are having curtain walls and support steel that is attached to the steel that we have modeled and a precast attachments.
Hmm.
So those drawings is like these are all like sloped ones and radial. Everything is there. So what we did is like we got CAD files of that particular panels and all. So we imported, including this video board connections. We
Hmm.
imported and placed in a correct place in the model so that we came to know where the connections will come up and it will clashes with the regular connections and everything. So send an RFI and again we receive updated connections based on our comments, again import it. It's a couple of times, so it makes us life like easy, like where we can attach these clips and all HSS stuffs into the model. Then it reduces errors and when it comes to the field it fixes very well. So that is there, and obviously we receive a lot of RFIs, addendum and all. So
Hmm.
we have
Hmm.
to attach those things wherever required, whatever supersedes. Just if we attach to the members, like it is easy to identify instead of tracking them. If we receive some information on the day one, take some time and put it in the model. Even after 2 weeks, 3 weeks, it's easy to identify. Even though
Yeah.
we keep the things like we have another tracking system, and if something goes wrong, we can cross verify each other. So that way we reduce the errors.
Yeah.
So that is what we
Very
have.
okay. Okay. So I flipped through a couple pictures here as you were describing that to us, but this one we're kind of starting to see must be that lighthouse that you mentioned in the background there, huh? So that
Yes, that is like a cone shape. So it
uh-huh.
is bigger on the down. Like if it is going up, it's like the area is reduces. So the columns are like sloped one and splayed columns. So
Yeah.
different types of geometry, and it's like 220 feet tall, I think, total.
H-
And there
Two
is the upper 220 feet height.
220 feet. Okay. Yeah. Here
You
we
see
see the
the,
backside. We can see the whole thing now here on this image
yeah,
from the backside. So yeah,
yes.
very cool.
There is an observation deck on the top, like just 10 feet below or 12 feet below from the top. There is an observation deck, and
Okay.
there are elevators in that, in
Uh-huh.
the like lighthouse tower. Like there are elevators, so we can
Yep.
import that elevator drawings into that. And the steel is so dense, like the connections are complex, so we can do a clash checking. Like if any members clash each other, we can do that clash checking in SDS2. So where we can see the members are like whatever it clash, it's easy to locate. And because of the geometry, like it's very difficult to make vertical braces and horizontal braces. So we have to go to the surface of member, put a temporary node, something, and locate the braces. So too many connections at one point. Hope you understand what I'm saying.
Yeah. No. Makes sense here. So this is good stuff. Good stuff. So and it looks like
So,
concrete on the outside of this observation deck, but I can't imagine that that's concrete all the way up, is it? Do you know what
oh,
the covering
yes,
here is?
that is precast panels. That is like it's a precast concrete panels. So which
Okay.
is brought to the site, and there is a connections between these precast panels. So based on these drawings, we have to make some steel connections to our steel.
Mhm.
So they are attached to together some by means of some fasteners.
Okay. Okay. Very good. Here we got another shot of that. So we're kind of seeing the steel, and then it's like half covered with those precast panels here. We're just kind of seeing
Yes.
from that side shot a little bit of it open, but yeah, And
Yeah,
actually
that
all the main structural steel looks like it's up in this shot. Everything's just kind of being that must be
yes,
all glass. It looks like all glass panels on this side, and then the precast panels on
yes,
that
correct,
observation
correct.
tower. Huh? Yeah.
Yeah, on the main building, it's a curtain walls, so all the glass
hmm
panels, and
hmm
whereas in lighthouse, it's like a precast panels.
Yeah. Very good. Very good. Ooh, this almost looks like it's a shot from that observation deck, but I'm not sure it is. Is it?
Yeah, I think so. Like it's not from the
Yeah.
observation deck. Maybe
Yeah.
it's from side of observation deck. Correct.
Mm-hmm.
What you are saying is
Mm-hmm.
correct.
Yeah. Okay. Okay. Here we got a little more steel going up. So you can see the iron workers up there on top there erecting stuff. So that's a cool picture there. Cool image.
So if you compare a human with the steel, you can see, imagine how big they are.
Yeah, I imagine just based on that size, it's got to be what? That's got to be a 36, 40-inch
Yeah,
beam
correct.
there.
It's
Yeah,
all like more than W36 and all.
36. Okay, yeah. So big stuff. Yeah. Okay. Now we're in SDS2. This is a shot from the SDS2 model. Looks like the whole
Yes, it's
kind of
SDS2
getting the
model
yeah.
screenshot.
Okay. We can see that lighthouse in the background. So it looks like your team even modeled in all the precast panels covering up that
Ye-
lighthouse too, huh?
Yes, correct. Yes,
hmm
correct. Like it's imported from like based on the precast drawings, and we have modeled. Like we have to see there should not be any clashes for that. So
Yep. Okay.
even
So they didn't model those precast panels. They imported that from a different model.
yeah, we have
Yeah.
imported some of them, and wherever there is a different, if we don't get a proper information, we also put some panels just to verify
hmm
the the alignment and all. Like if we miss anything, like it will be like huge things in the site. So
Yeah. Okay. Okay. Very cool. And here we're kind of seeing the backside again. Must have turned off that reference model so we can actually see inside that. There's a
yeah,
lot. Looks like there's a lot of steel in there. There's a lot happening in there.
yes, it's almost 3,000 tons job.
Mhm. Yeah. So that just in that lighthouse itself, it just looks very
Yeah, that is
compact,
so
very
dense.
busy, right?
Too much like a dense steel because it's like all braces and there is
Uh-huh.
a elevated steel. Too much steel in that portion.
hmm hmm
But the heavier members are in the main steel because of the span and it's
Yep.
supporting all video board and
Okay. Very good. Very good. And here we've got, okay, so we're seeing this at a plan view. Looks like labels on there. So we're seeing a market area plan view, level 5 plan view. So,
so these are
uh, yeah.
different levels. Like market area is a lower
Mhm.
one and level 5 is a bit higher. So different levels.
Yeah. Okay. Very good. Very good. And I can really start to see you talked a little bit about some of the geometry and different angles and everything going on there. So we can really start to see that as we see some of these images from the model. Not a lot of, there's not much, I mean, obviously, like a lot of the steel is straight, but we're not really like just a square
It's
corners or anything. Everything's always kind of segmented
segmented.
and
Yes, correct.
connecting at different angles, right?
Yes, these
Yeah.
are like all these are like inclined radial ones. So
Uh-huh.
every grid location with some angle skewness.
hmm hmm
So we have to locate all of them in a correct place. So there will be a lot of questions itself, placing the grid
Yep.
lines.
Yep. I can imagine. Looks like it. So and here we really start to see, so you described some of the trusses.
Correct.
to us earlier, and we really see some of those here in these model shots. Then there's that some looks like a real big heavy one here, kind of in the middle of all of that going on there, right?
Yes, because of spans, like instead of beams, they made it with the trusses.
Mm-hmm.
So we have like apart from video board frames, I think we have 37 trusses in the project.
Okay, yeah, very interesting. And here, yep, kind of get a little bit different view of some of those trusses and stuff going on there. So, and
Yes,
it looks
correct.
like we've got they're not just not all of them are just a straight truss. It looks like uh this one, so this one down here at the bottom interests me, is the
Yeah,
bottom cord. Is that one truss going across the whole way, or is that two trusses there?
it's a one truss, like between two
One
columns, one
truss.
truss, and the back side is another truss. Some
Okay.
are
Yep.
cantilever trusses, like supporting skewed columns again.
Mm-hmm. Mm-hmm.
Yeah.
So it looks like I always find it funny when I look at stuff like this. So the connection plates for those trusses are almost bigger than the cord piece. It looks like in there.
Yes, some of them
Yeah.
are like that.
There we go. Here we get a little bit more detailed shot of that truss and kind of the connections going on
Yes.
there and happening. So, like WT, were they WT cords, or are those double angle cords? What
No,
are those?
WD cords and like
WT.
the inside braces are double angles.
Mm-hmm. Yep. Okay.
And there is some white flange things also there.
Yep. Yep. Very
You can
good.
see that in different pictures, I think.
So there's a lot happening in this image. So you've got like the cruciform columns coming up. Looks like you've got a splice in the cruciform columns, and
Because
then it looks like we have got a sloping wide flange column on top of that, and then another wide flange column on top of that, sloping at a different angle.
so for erection purpose, we made a splice at the bottom column, and the small splice piece and the sloped one, the upper column, will be like we have assembled in a shop and shipped to the
Okay.
site. So it's
Mm-hmm.
easy for erection in the field.
Makes sense. Makes sense. Yeah, there's a lot happening there. I can imagine how difficult it was to coordinate all that, figure all that out, and detail it and that. So, and then you've got a truss in the middle, multiple trusses in the middle of all of that going on. And it looks like we have. Is this probably on the outside? That's probably support for those.
That curtain walls, like
Yep.
those steel is curtain walls, and you see the bent plate also sloped. So there are some
Oh, yeah.
attachments made in those columns just to support curtain walls.
Mm-hmm. Mm-hmm. Yeah. Very good. Interesting stuff. There's a lot happening here, so very interesting. And this is another really cool one. So this is a bit heavier truss than what we just saw in that previous image, right? We've got
yes.
the top cord looks flat, but the bottom cord is sloping here.
Yes, these are all made out of W members, and because like you see the span and that is supporting another columns which is running to upper concourse, so that's why they are that much huge.
Yeah, those are quite large. And then you've got, look at the paddle plates on those wide flanges connecting to your gussets. It looks like there's how big are those plates? Do you know?
Yeah, that is another truss which is running between the cruciform columns, and that truss which is perpendicular to these trusses is supporting these trusses. So that's why like you see all these crazy connections.
Yeah, it's very crazy. And the bolts, there's a lot of bolts in there, isn't there?
Like at some junctions, like there are more than 200 bolts.
Yeah, that's crazy. So very cool. I love just looking at this type of stuff and just
Yes.
yeah, all very interesting to me. So
So this is a video board supporting frame.
Okay. Frame that supports those big video boards we were talking about
Yeah,
earlier then, huh? Yep.
correct.
Okay. Okay.
So these are made between like a frames between column to column. Like it's like supported by all cantilever beams. So it made like a bigger frames.
Mm-hmm.
So
Mm-hmm.
just they bring in and they insert into the place.
Yeah. Okay. Very cool.
So here we used like a group members. It's like they are all detailed individually, but made it as a group
Mm-hmm.
and submitted to the shop. So they
Mm-hmm.
make all the fabrication individual pieces and they assemble in the shop and
Yeah.
ship to the
Okay.
site.
Okay. Very cool. And stuff like this always kind of perplexes me a little bit. So those look like tube. Are those tube braces?
Yes, we do have two braces in this.
Yeah. So they almost look out of place to me, right? Because you've got these giant cruciform columns on each side, and then it's like kind of small tube bracing
Yeah.
in the middle. So it almost looks funny, like they're almost too small. But I'm sure an engineer who did all the math and knows more than I do calculated it all out properly, and everything's going to be good, right? But it looks kind of funny.
Yeah, it's like a lot of checks will be there. Obviously, like
Yeah.
it will be like they must be like a very experts to do this kind of connections.
Mm-hmm, mm-hmm. But then the bolts. Look at all the number of bolts that are in there. There's just bolts everywhere, isn't there?
Yeah, it's all
Yeah.
bolts because this
Yeah.
is a stadium. There will be vibrations,
Mm-hmm.
so that's why they prefer like bolts instead of welds.
Sure. Okay.
There must be
Okay.
some welding, but that's what I think.
Mm-hmm.
Earlier also we have done some arenas, and in that also like we see a lot of bolted connections.
Yeah. Makes sense. Okay. And this is interesting here also. So a couple different shots here. So it looks like yeah, you've got an elevation of that video board support.
Yeah.
And then here we see some of those the joints that had to be able to slide a little bit that you were describing
Yes.
earlier, right? The expansion joints.
This is not expansion joint. It's a video board. Yeah, there
Okay.
is a video board like must be there because that is fully covered. There must be wind loads, maybe
Mm-hmm.
because of their size. So obviously there should be like a slight adjustment
Mm-hmm.
to adjust the forces, I think.
Okay. Okay. And then this top image is interesting too. So that must be is that a tube column in there, but it's split about 4 times with plates in there. Is that what I'm seeing?
Yes, correct. Because that all are movement connections. So there is a plates in between.
Yep.
So that beams are welded to that plates. So
Mm-hmm.
that cannot be possible to a tube, maybe because of loads or various reasons. So
Mm-hmm.
that all are like full penetration welds. So we have no option like there is a small gaps like 1/4 inch or 3/8 inch gaps between the tubes and the plates that will be like welded, filled with
Okay.
all the weld.
So are there looks like those tubes, so kind of hard to see, it's a little bit far away, but looks like the tubes are prepped, so there's like a full pen weld all
Yes,
the way
correct.
around those tubes welding to those plates.
Yes, correct.
Yeah. Okay. Okay. I'm
So
guessing the fabricator was upset about that. That's a lot of welding and a lot of labor for the
yes,
fabricator to do stuff like that, huh?
yeah, like the fabricator is Siva's North England division. So they are
Uh-huh.
pretty much experts. So they have done so many projects. So we have been
Yeah.
working for them like more than a decade. Like it's
Mm-hmm.
almost 15 years, I think.
Mm-hmm. Okay. Okay. And we've
So
got another slide expansion
they,
joint here. So yeah.
yeah, there is a continuous expansion joint in the building, so there is a slide bearing connection
Hmm. Hmm.
at that expansion joints.
Very good.
So
Very cool.
there is a movement allowed in that particular connections.
Okay. And
So
what's going on here?
this is another slide bearing connection at existing steel. So there is an existing steel and the new steel is connected. So it is pretty much similar to the expansion joint, but the difference is at expansion joints, both ends are new steel. Here it is the existing steel on the right side.
Hmm. Okay. Okay. It's like kind of a close up here of some of that. Then is that right?
Yeah, so like it is a perpendicular view of a video board connection at one junction. You see, if you see, it seems like both are in same plane, but if you see on the plan, both are with different angles. So
Yep.
these two bolts are movable. So we have made like they are in the same line. So this is an average angle of both the directions, so that video board can easily move along long direction.
Hmm. Hmm. Are those are those back-to-back channels that I'm
No, they
seeing
are
there?
assemblies of plates and fabrica pads.
So, but above that, what we've got running like the cross section of what I'm seeing here are these
Oh yeah,
channels?
yes, that
Yep.
is that panels.
So those are back-to-back channels, probably some sort of spacer plate in the middle there.
Yes, correct.
Yep. Okay. And I'm not even sure what to say about this or what there's stiffeners everywhere. There's bolts everywhere.
Yeah.
Yeah. I don't know. What do you say about this one?
Like the columns, like multiple members are coming and framing to this column. So that is a design requirement where we have added the stiffener plates at each flange of that particular members.
Hmm.
So just maybe small movement connections and heavy connections. So
Yeah,
for that,
there's just a ton going on in this picture.
yes, correct.
How and then so those stiffener plates look quite thick. So they're all prepped. So I gotta assume there's some pretty
Yes,
heavy full pen welds in there just for the stiffeners alone. How
yes.
big or how thick are those stiffeners?
It depends on the flange thickness. We are having like in some places like 1.5 inch, 1/4 inch, and 1 inch. A lot of varieties of stiffener plates are there.
Yeah. Is it? Yeah.
Some are like a 1/2 inch also there. It depends.
Okay. Okay. Another good shot of the lighthouse here with an isometric view, kind of seeing that isolated a little bit and
Yes.
just kind of understanding and seeing how much steel is actually in there. That's cool. And a shot from the top here. So this must be looks like a plan view of that lighthouse from the top of it.
Yeah. Yeah, it's from the top view. You see, like it's going down like a lot of bigger, like its area is increasing.
Yeah. Yeah. Very cool. Couple elevation views, kind of looks probably like we got a section cut through the middle or the sides of that
Yes,
a little
correct.
bit.
Yes.
Mhm.
So these are,
And yeah, there's a lot going on in this one again. So there's like connections and plates and bolts everywhere. What's happening
so
here?
here we are having like splayed columns and horizontal braces, vertical braces are
Hmm.
coming at same junction. So that's why the connections are so complex. Apart from that, there is a like precast panel supports also there.
Hmm.
So that makes like a very complex connections.
Yeah, very.
So they cannot like erect. So what we have done is like they are shop assembled at that particular junction and all splices made. So if you see the yellow color ones are like the shop assembled, and the blue ones are like
Got it.
field. There is a splice there.
Yep, that makes sense. I see that. Makes sense. So, and again, pretty heavy. Looks like everything's prepped for full penetration welds and
yeah, all pretty heavy stuff. All are full penetration welds.
Very interesting. Looks like probably kind of just some different angles of some of those different connections then
different
here.
connections in different angles.
More very similar stuff here. There's bolts everywhere. There's plates everywhere. There's just so much going on here. So here's that observation deck you were talking about also then, huh?
Correct.
Yeah.
This is observation deck.
Okay. Very cool. And we've got
it's a complete
looks like
roof plan.
Yep. And are those, so it's kind of a tube structure, are those kind of like almost like trusses? Would those have been assembled in the shop and erected as probably about what, 1, 2, 3, 4, 5, 6, 7, about eight pieces just to erect then? Yeah.
Yes, correct. All of them are made shop assembled and field assembled, like shop assembled and field brown.
Yep.
Erected ones.
Very good. And here we've got says a lighthouse built up column view. Tell me about this a little bit.
This is like a splayed columns. So up to certain level, it's a sloped column, and it's split into the 2 columns. And because of that, when it started splitting, it's like the bottom portion is too complex. Like what they have done is like they made a column with a built up members, like built up plates. Up to certain height, they get a free space. So that made into like the built up column is one part that shipped, and there is a splice. Again, the 2 different columns came. So like that particular junction, we have made 2 comes and 2 splits, like 4 columns at one junction.
Yep. And then so, there's some of the connections then it looks like some of the connections up there are kind of connecting the columns that split.
Yes.
But things coming in there like you're connecting to both of the columns that are split, right?
Yes. Apart from that, we need to place this precast panel supports also. So that's why the connections are so clumsy, complicated.
Yep. That's that's quite interesting here. This is quite the project. And then again, I'm not even sure how to describe this, I guess. So I'll let you do your best to describe what's happening here.
There are 2 different connections. Like one column is supporting another column, you see on the picture. So there are connections made between the 2 columns. Like it is stopping on, it's starting, and it's like starting from on there is no base. It's supported by the parallel column. So that's why there are too many connections to give a firm connection. We receive so many connections for that.
So there's basically a column floating out in space that you had to figure out some crazy connections from another column to support this column hanging out in space, essentially.
Yes, correct.
Yeah. So was this all shop assembled?
Yes, like the columns are not shop assembled, but the connections are like bolted, field bolted, or temporary erection bolts are there.
Yeah. Okay. This one kind of blows my mind a little bit, actually.
Yes.
Got some more kind of crazy connections happening here, huh?
Yes, correct. So you see that observation deck, that is a cantilever member, which is supporting all these observation deck members. So that's why that's a movement connection again. And that is a slate column. So 2 different directions it is going.
Oh, that's one of those split columns that we saw in a couple pictures ago.
Yes,
Got it.
correct.
Yep. And
It's another elevation view.
yeah, I don't know. Describe this to us, I guess.
It's a bottom side, so just there are sloping
Okay.
columns because two columns are supporting at the bottom, and you see that is some overhang portion are there. That is only in one direction. It's not for our entire lighthouse. It's only in particular area.
Got it. Okay. Yep. And so here we really get like a elevation view and kind of a section of what you were describing earlier, those joints that were pretty heavy joints, but they're all shop assembled, and then we got kind of the splices going on there, right?
Yes, that particular junction is shop assembled, and all are made with the splices.
Yeah. Yep. And you know what? I have to apologize to our audience who doesn't get to see these images, because I don't care how much we try to sit here and describe it and put it in words. There's no way for us to really actually put this into words, what we're seeing on a lot of this stuff, as crazy as it is. So pretty wild, yeah. There's a little bit more of so we're seeing the supports really now for those precast panels that cover that lighthouse, right?
Yes, so you see how they are sloped. So that's what we want to show. Like, this is not a two-way slope thing, so it's like falling like this.
Yep.
So and this direction is coming. So just to locate them is connections are like, see, once we locate them properly, we can make the connections. But locating them is like we have to do a lot of trial and error methods, and we have to send a lot of RFIs, a lot of coordination. It takes a lot of time in the coordination.
Yeah, sure. Makes sense. I can understand why it takes a lot of time for coordination here. Yeah.
Yeah.
And this is our last image. What do we got on the last image? So looks like a bunch of more crazy connections to me.
Yes, like this is all in the main steel, like main building. So different levels. So whatever the connections, we see that like a sloped column in the main building, so which is supporting another bigger beam, and there is one more column coming up over the beam, you see, and this is a slide bearing connection on the bottom side.
Okay. Yep, I see that again.
Curtain wall support on the top left one. The HSS tubes attached to the column. It's a curtain wall support steel.
Yeah. Very good. Well, you know what? Great job to you and your team. Looks like that was quite the project to work on. So, yeah, great job.
I would like to thank on this platform like Jonathan Hammond from Sivai NED. So I was working with him like more than a decade, close to a decade. He's such a personality who gives a clear-cut response. So if you are having any doubts in mind, and if you ask any question, it's so clear that, and it gives us some confidence. His team and the Cary Grant, he's an expert in SDS2. We call him, he's our SDS guru. If I have any question, just call or send an email to Cary Grant, and he's our, like, he gives us some kind of a solution or response.
Yeah, very good.
And my team, like, I'm having a really great team, because to do this kind of a project, people are really have a lot of patience, and they have a lot of knowledge, because making this many connections, complicated one, it's not going to happen in like some connections take a day. So they have to be very patient, very keen, they have to be look at very in detail. If something deviating, they have to ask questions. So like thousands of questions we have to prepare and all. And our management, like at a certain point of time, like we were working like 24/7. We made people to work on the shift. So I think for 2 months, like it's a weekend or midnight, whatever. At any point of time, some set of people are working. So our
Mm-hmm.
management took care of them, like providing like whatever the amenities required.
Yeah.
So
What
it's
what was the timeline like on this? So like from start to finish, do you
like
know, remember how long it
it's
was?
around 6 months, but there was a period of 2 months. It's a very peak because we are simultaneously submitting the approval drawings and fabrication drawings and questions from the field, corrections and all.
Mm-hmm.
So we made like four batches or 3 to 4 batches, and each batch coming in different timings just to meet the requirements.
Yeah. Okay.
So all coordination done by my project manager. His name Raju. So he's a very good person. Like he's expert checker for us.
Well, he certainly must have done some great coordinating on this project.
Yes, correct.
Very good, very good. Well, we don't typically make a podcast this long, but we had a lot of interesting stuff to look at here. So, it, you know what? I appreciate you guys coming on here on the podcast with me again. Said at the beginning here, thanks for sending me the whiskey. I very much appreciate that. Uh, I just again want to reiterate a little bit here. So this project was one that won an award from our solid steel competition. So we've got the entries for the solid steel awards open a little earlier this year than we normally would. So they're already open. So you don't have to give away any secrets, but do you have something up your sleeve, some sort of crazy project again that you're going to submit for the awards again this year?
We are
Yes.
having a couple of things, but like we are checking. So we are planning to submit 1 or 2 projects this year
Yeah.
also.
Okay, very good. I can't wait to see what it is. So
Yes.
yeah. And for everybody else listening, make sure you submit your SDS2 project for our Solid Steel Awards, please. The more the better. So yeah, we always like to get those projects. We always like to showcase what our customers are doing and showing off what's possible with the software. So it's very good. Okay. Madhu, Amol, again, thank you. I appreciate your time. Thanks for joining me. And cheers from me. I hope you get to escape the office and enjoy a drink yourself here pretty soon. So
Yes.
yeah.
Tomorrow is weekend, so definitely we'll do. And next
Very
week,
good.
Amol is coming here, so definitely we'll have a party.
Sounds awesome. So, okay. Very good, guys. I'm sure we will chat again in the future.
Yeah,
Definitely.
thank you very much. It's a great
Okay.
pleasure to talk
Thank
to
you,
you.
David.
Yeah.
Have a good weekend.
Thank you.